Cloud computing, the Internet of Things, data-based decision making. Computing today is a fascinating collision of physical and material. Historically, computing was essentially the use of something physical to help us do something theoretical, namely math. The first computational tool we know of was the Sumerian abacus, followed by the Chinese abacus. Charles Babbage first imagined a mechanical computer named the Analytical Engine in 1837, and Ada Lovelace developed the first algorithm for this machine. Women were the first computers, that is, people who were hired to compute calculations for missile projections during the Second World War. Alan Turing used vacuum-powered tube technology to develop the Turing machine, which did the calculation necessary to decipher Nazi codes. Our world today revolves around the seemingly mundane and humble chipboard. If you've ever cracked your PC or any electronic device open, you've probably seen one of these. The silicone microchip inside was first invented in 1959 by the combined innovations of Jack Kilby and Robert Noyce. Moore's law, predicted in 1965, suggested that the number of transistors per silicon chip doubles every 2 years, which means, in layman's terms, that the amount of data that can be stored and computed by a chip increases. Our technological devices have become smaller and more capable rapidly within the past 100 years. The digital world was born in the 20th century. Personal computers, the internet, smartphones, artificial intelligence, and more are technologies that build on earlier innovations. Information and communications technology today allows for the exchange and use of information in digital form. So what's happening today? Physically, because of rapid changes during the pandemic, we don't have enough chips to go around, and we badly need these to run everything from cars to medical equipment to computers. The large amount of data available because of the exchange of information on the internet has given rise to big data computing. Alright, so the very first part of this week's topic is simply what big data is. We'll be looking first at a video and then reading an article. Imagine keeping a record of every single thing done on Facebook for 10 minutes. Just 10 minutes, everything that every single Facebook user is doing. All the data that's being collected. Imagine how much data would that be? It would probably be a crazy amount of data. Now imagine collecting all the data from Google searches and YouTube and Gmail for 24 hours. That's even more data. Now imagine collecting everything that everyone does on the internet all the time. That's big data. Volume, velocity, and variety. Unlike quantitative research, you are essentially just scooping up everything, keeping a record of everything, and deciding what to do with it later. It's not that it's particularly complicated data, it's just that there's so much of it and people are still figuring out what to do with it. The difference between quantitative research and big data starts out with the process. So quantitative research, you determine beforehand what you are collecting and you collect it in very isolated and specific circumstances. However, with big data, like I said, you're just taking a big scoop and dumping everything in a box and figuring out what to do with it later. It's just like a bunch of things in your cupboard that you put aside and you keep piling up, and then now you've got to figure out, oh dear, what is it we do with it? A website like YouTube has to automate what they do with the data. So they have algorithms that look at your viewing history. No one is manually looking at your viewing history and telling you what to watch next. They're simply using the data from your viewing history and calculating it using predetermined algorithms, which YouTube doesn't even know what its algorithm does and how it works. It simply knows that it is what it is and it does what it does, and it recommends videos to people based on what they've watched. Forbes is a business publication and considers big data from a business perspective, such as for small businesses and how they can, take this kind of data and use it to enhance their productivity, their customer reach, and so forth. However, two main things to look out for. What are the 3 V's of big data? What are they conceptually not? Secondly, you can consider this quote: how big data takes unstructured data and extracts ordered meaning. Do you think that this process is challenging or easy? What can this be applied to? What can the product of big data processing be applied to? It's interesting to consider the use of the data, like this big pile, this landfill of uncategorized, unprocessed data, as being like an unknown. It's a pioneering field. If you get into it, you really don't know. You need creativity to actually decide what to do and how to go about doing it. So according to Patil 2011, being a data science ingenieur or being a pioneer or inventor requires technical expertise, curiosity. It's all outside of the box. You do have skills, but you also need to think about new things that can be done with the data. And then you have the storytelling skill that we've discussed in weeks 1 and 2, the ability to use data to tell a story and to be able to communicate it effectively. And finally, cleverness, ingenuity. And the reason why I think this really stands out to me from the Forbes article, this was linked, is because learning skills now in the 21st century requires these things. We build upon technical expertise, and then we need something more. We need like the X factor. We need to be able to go outside the box, to pioneer something that's not been done, and then we need to be able to be creative, to tell stories, to communicate effectively with people. This is literally the skills. These are the skills that we need to be developing now. So for this next section, we're just, starting out in the whole concept of big data. We're still thinking about it in terms of what is it. So let's look at 4 case studies, 4 examples of how big data is used, and let's simply just think about them and talk about them. We're not going to go into huge detail right now this week, but we're just starting out. So these 4 case studies will be hopefully thought-provoking and informative ones for you. This first article by Giorgia Lupi is fascinating because the approach to data, big data and data visualization is so different. Instead of seeing data as alien to the human experience, something very distant and digital and large and aloof, the author makes it personal, small, imperfect, analog, handwritten, and changes the quality of our interactions with data and the way that we understand and visualize it so that we can incorporate it more into our lives and also into the way that we interact with the world as human beings. There are some questions we can consider. Firstly, how does Giorgia Lupi suggest we approach big data differently? How did the Dear Diary project use data differently? What elements contributed most to the story and creativity of the project? Which part of the project did you find the most interesting? And what do you think Giorgia Lupi meant by imperfection? Here is an example of a use of big data that required creativity to look at a problem in the world and to want to use data to find the solution and to come up with a process algorithms and programs and so forth for working out the solutions. So take a look at the video and consider the problem and solution aspect of this particular application of big data. Check out one or both videos about the Cambridge Analytica scandal, where Facebook data was used to manipulate election results by, in an unscrupulous and unethical way. Some questions we can consider after having looked at positive uses of big data include: in your opinion, should humanity deal with the wild west of big data and the potential for manipulative or invasive or unethical uses? Should big data be regulated? How does one regulate something that is still being, gradually explored and understood? Do the benefits outweigh the risks? Will regulation stand in the way of progress that can really benefit humanity? Finally, this short video discusses the social credit system in China, where big data is used to protect, the public good for law and order, and now during COVID-19, the protection of public health. Some questions we can consider include: do you agree or disagree with the use of big data by governments to enforce law and order or public health and safety? How should this generation and future generations develop safeguards against potential abuses of big data? We have really just touched the surface this week, and we will be revisiting this subject in future weeks. So stay tuned for that. I hope that the case studies, especially here, are useful. And what we're going to do in the tutorials is we're actually going to look at this from a personal perspective, from the perspective of our own lives. See you guys in tutorials and have a great week ahead.